Okay, we're going to now be solving exponential equations. Before, we could solve a linear equation by isolating x using our inverses or our opposites, such as division is the opposite of multiplication and addition is the opposite of subtraction. So when we solve exponential equations, we have a variable again, and the variable is in the exponent position. So we want to undo that. So when we undo, we first of all want to look at the log that we have. And if I just have the word log, we need to remember that's base 10, and that's our number system. And we can use the calculator. And ln is base e, where e is that number, 2.71828, etc. And so what we want to do is look on our calculator and find those two log buttons. And you can see right next to the 7, in this position here, and right next to the 4 is e and base 10, log, and natural log. So what we're going to be doing here is trying to isolate x. I could guess and check, and I can see that approximately between 2 and 3, because 3 squared is 9, 3 cubed is 27, 15 is someplace between there. But I want to really bring that down. So what I'm going to do is I'm going to go logging. And I like to use a common log. However, the natural log will work as well. Property 3 from my property from logarithms in the previous section says using my property that x comes down. Now if I'm going to solve for x, divide by log of 3. Now I can't take 15 divided by 3 or cancel my logs because I'm looking at exponents, because that's what a logarithm is. So if I type in log of 15 and I divide it by log of 3, I get an answer. And therefore, if I take 3 raised to that answer, I better get 15. And I better raise it to the answer. And I get exactly 15. Now, there's no way you could have guessed and checked that all the way out to that. Well, I guess you could have, but it would have taken a long time. So before I go logging, again, I need to isolate. So the first thing is that I'm going to divide by 2, and I get 3 equals 4 to the x. Again, I'm going to go logging. And the purpose of logging is to take that exponent using my properties. It says the x comes down in front, and I'm going to divide by log of 4. And again, I could check that on my calculator. In this case, before you go logging, you must subtract the 3. So I get 5 equals 2 to the x plus 1. When I go logging, the whole purpose was to bring that exponent down. Log of 2 base 10 is just a number, which I can divide both sides by that. And then the last thing to solve for x, I need to move this 1 over. Negative 1 plus log of 5 over log of 2. So plugging that into my calculator, I get negative 1 plus log of 5 divided by log of 2. And that would be my answer. So plugging that in and adding it, but I think I need to go back here, negative 1 plus log of 5, close it up, divide by log of 2, should give me a positive number, there we go. So if I take that, add 1, and then take 2 to that power, and at the end of that I need to add 3 in my problem. So what I'm doing is just plugging it back into the problem here, and I get 8. So looking at the calculator, I just went back and I plugged it in this position. Okay, number 4, this base is an e. So I'm going to use a different kind of log on this. I'm going to use the natural log. Natural log of 3. Why would I use a natural log? Well, when you have a base, you want the log to match that, so they undo because they're opposites. So 1 minus 2x, natural log of e equals natural log of 3. From our properties, the natural log of e is 1. So solving this for x, negative 2x equals negative 1 plus natural log of 3. Divide everything by negative 2. And again, now you've solved for x. So we solve logarithms or solve exponents by using logarithms, and actually we solve logarithms by converting those to exponents. So this concludes the lecture 1 for section 4. Back there.